Very good morning to dear students. Yesterday I told you about the Rate law equation for zero order reaction, first order reaction and their graphical representation. Today I'm going to solve the numerical portion related to these topic. First numerical is the rate constant for a reaction of zero order in a A is 0.0030 mole liter inverse second inverse. How long will it take for the initial concentration of A to fall from 0.10 to 0.075? Okay, students, so what we have to given here, K equals to 0.0030 mole liter inverse second inverse. Okay, and here initial concentration R not equals to 0.10 m and R equals to 0.075 m. Student, we know for a zero order reaction what K0 equals to R0 minus R upon small t, and small t equals to R0 minus R upon K. This is 0.10, 0.075 upon 0.0030. So it becomes 8.33 second. Okay, students, so solve these question like that. Okay, now the next one is the decomposition of N2O5 at 300 Kelvin according to the following equation follows first order reaction. N2O5 gas gives 2NO2 gas plus half O2 gas. The initial concentration of N2O5 was 1.24 into 10 to the power minus 2 mole liter inverse, and then after 60 minutes was 0.20 into 10 to the power minus 2 mole. Calculate the rate constant of the reaction at 318 Kelvin. So students, we know that for first order reaction K equals to 2.303 upon T log R naught upon R. Okay, student. So here time equals to what? 60 minutes. 60 minutes. Okay. Initial concentration R naught equals to what is 1.24 into 10 to the power minus 2 mole liter inverse. Okay, students, now here R is given, that is 0.20 into 10 to the power minus 2 mole liter inverse. Okay, now put the value K equals to 2.303 upon 60 into log R0, that is 1.24 into 10 to the power minus 2 upon 0.20 into 10 to the power minus 2. Minus 2 cancel out by minus 2. It becomes 2.303 upon 60 log 6.2, and it becomes 2.303 upon 60 into 0.7924, and from here K becomes 0.0304 minute inverse. Okay, students, so this is the rate constant of the reaction at 318 Kelvin. Okay, now the next one. The decomposition of a compound is found to follow first order rate law if it takes 15 minutes for 20% of original material to react. Calculate. Number first, the specific rate constant. Second, the time at which 10% of the original material remains unreacted. Third, the time it takes for next 20% of the reactant left to react after 15 minutes. Okay, student, first we know that for first order reaction. What? Just a minute. First order reaction, K equals to 2.303 upon T log R0 upon R. Okay, student, let let R not equals to, means initial concentration equals to 100. Then R becomes what? 100 minus 20, because 20%, so it is 80. Now K equals to 2.303 upon, it take how much time? 15 minutes for 20%. Okay, so it becomes 15 log 100 upon 80. Solve this, it becomes 2.303 upon 15 into 0.0969, and it becomes K equals to 0.0149 minute inverse. Okay, students, now the second part, what is it? If in second part we can write, if R not equals to 100 and R equals to 10. Why it is 10? Because it says the time at which 10% of the original material remains unreacted. 10%. Okay, so here we take 10. It means now T equals to 2.303 upon K log R naught upon R. Okay, and 2.303, what is the value of K? Just we calculated 0.049 into log 100 by 10. Okay, so time equals to 154.6 minute. I think it is clear to all of you. Now the third part. What is third part? The time it takes for the next 20% of the reactant left to react after first 15 minutes. It means, student, what? First 15 minutes may it consumes 80%. So now if R not equals to 80 and R equals to 80 minus 20% of 80. Okay, so it becomes 64. Okay, students, now T equals to 2.303 upon K log 80 upon 64. And now 2.303 and the value of K is this, then 0.0149 into 0.0969. Okay, so now it becomes T equals to 15 minutes. Okay, so solve these type of numericals like that. Okay, now students, the next topic is half-life period of a reaction. The student, as name announce, half-life. Half-life means the time during which the concentration of reactant is reduced to half of its original concentration. It means if the original concentration is 100, after that time it becomes, after what time it becomes 50. So this is the half life. Again listen, the time during which the concentration of reactant is reduced to half of its or initial concentration. Okay, student, half life period is represented by T half. So first calculate T half for a zero order reaction. If A equals to product, okay, then rate constant K equals to, we know that for the zero order reaction R0 minus R upon T. At half life T becomes T half, R becomes R not minus 2 because initial, half of the initial, then K equals to R naught minus R naught upon 2 upon T half. So it becomes T half equals to R naught upon 2K. Okay, like that for a first order reaction A gives product, and we know that for the first order reaction T equals to 2.303 upon K log R naught upon R. Yesterday I derived this. At half-life time, what happened? R becomes R naught by 2 and T becomes T half. So T t half 2.303 upon k log r naught as it is, and r becomes r naught by 2, and so t half equals to 2.303 upon k into log 2. Okay students, now put the value of log 2. So t half equals to 2.303 into 0.3010 upon k, and it becomes 0.693 upon k. So this is the formula for the half-life period of a first order reaction. T half equals to 0.693 upon k. And for the second order reaction, we know student Kt is equal to 1 upon R minus 1 upon R naught. At half-life, what happened? T half equals to R and R equals to R naught by 2. So Kt half equals to, now when we put here R naught upon 2, then 2 becomes as a numerator. So 2 upon R naught minus 1 upon R naught. So it becomes 1 upon R naught. Okay, and T half becomes K 1 upon K R naught. Okay student, so this is the formula for the calculation of the second order reaction. Okay students.
Now numericals related to this topic. Calculate the half-life period of a first order reaction where the specific rate constant is for the first 200 second inverse. So students, we know that for the first order reaction, T half equals to 0.693 upon K, and for the first part K equals to what? K equals to 200 second inverse. Okay, so T half equals to 0.693 upon 200, and it becomes 3.465 into 10 to the power minus 3 second. Okay, now the second part, 2 minute, it means T half equals to 0.693 upon 200, 2 minute, है ना, 2 minutes, so it becomes 0.3465 minute. Now the third part is 4 year, it means K equals to 4 year, then T half equals to 0.693 upon 4, and it becomes 0.1732 years. Okay students, now the next question. A first order reaction is found to have a rate constant K equals to 5.5 into 10 to the power minus 14. Find the half-life period of a time. We know for the first order reaction T half equal to 0.693 upon K. So it is 0.693 upon 5.5 into 10 to the power minus 14. Okay. So it becomes 1.26 into 10 to the power 13 second. Okay students, so solve this type of numerical in this way. Okay student, now if you have any problem in this topic, then please share with me. Thank you.